Okay, it's time to look at a few polar graphs in a different way than we have in the past. First off, r equals sine of theta. You should just kind of know how this one looks, so I'll show you. This is how sine looks. It's like a little circle sitting right with its base at 0, 0, and the highest it ever goes is 1. Now, that should be kind of reminiscent of how sine goes up and down and the highest it ever goes is 1. It's a little different because this one, the bottom of this one's at 0, 0, but this is how it looks in polar. We already talked about how r equals 1 would be a circle with a radius of 1. Now that just goes all the way around the center with a radius of 1. Now, would those two intersect each other? Absolutely they would. Look at that. We can see where they would intersect each other. Now, to find the spot where they intersect each other, what you do is you just think of these as two equations and you use substitution. Say r equals 1, so you stick a 1 right there. And now you have 1 equals sine of theta. And then you just think through circle trig and you go, where would that be true? Sine of some angle equals 1. Oh yeah, this isn't one of those kind where you draw a triangle. This is one of the quadrantals. And so sine would be 1, where y is 1, and that's this spot. And that's 0, 1. And I've taught you that sine is the y, and so that's this. And so yay. What's the angle then? That's the question. Sine of what angle equals 1? The angle there is pi over 2. So now you might think the answer is just pi over 2. But remember, that's the theta. The question is, what's the r at that spot? Remember, we are in polar. So theta, and I just said pi, and I meant pi over 2. Sorry about that. Theta is one piece of the puzzle, but the other is the radius. So it's this point right there, which is what comma what? We need an r and you need a theta, and r is 1. So 1 comma pi over 2 is where those two touch. The red circle touches the blue circle. This was me just calling out the answer with that little circle. So it's where the red circle and the blue circle touch. So what if you had another one like r equals 2 and r equals sine of theta? Well, it's as simple as you'd think. R equals 2, stick a 2 right there, and you got 2 equals sine of theta. And think to yourself, when you remember what sine looks like, right? On a normal graph, not a polar, normal graph of sine, it just goes up and down and up and down. What's the highest it ever goes? 1. So when is sine going to be 2? Never. That means there's no solution. Okay, so let's think through what that would mean. If you graphed this in polar, it would have a radius of 2. It would go out 2 in every direction. So this is polar now. So there's my circle. And the graph of sine, I showed you that before, it just kind of looks like this. A little circle sitting right with its base at 0, 0. And look, they don't touch. So it makes sense that there's no solutions. All right, so we solve these by substitution and using algebra like this, and then using circle trig if necessary, but sometimes we get answers where there's no solution. Okay, so one last thought. If this one's where sine is, then what's r equals cosine? Well, that in polar is just a little circle. Same deal where it goes out to 1 and it touches 0, 0, but it's to the right. So cosine's to the right, sine sits up on top. And that's my whole lesson for today on your async day, is talking about where things intersect. All right, so now you can practice that over on the Schoology quiz that I've put up for you. And that's all I have for you for today.